Good morning. Hello, everybody. My name is Renato Medeiros, and I worked with Mateus Basso, Guilherme Chinelatto, Gabriela Fernandes, and Professor Alexandre Vidal. My work is entitled as Reworked the Past in Pre-Salt Sections, an example of the top of Barra Velha Formations in Santos Basin. This presentation is structured as follows. Firstly, we go over the introduction, then we take a look at the results, which are divided into two parts, and lastly the team interpretations. The highlighted well was the first described in the project, and this is one of the shallowest well in the pre-salt, located on a structural height, occurring at the depths directly related to the Lula finger. In this work, we had access to the last 40 meters of the well sample core, corresponding to the red box highlighted. However, we had access to the thin section of the total well. According to the oldest work of the team, this well is not dominated by the vug porosity, but by the matrix porosity. However, it is still one of the most producing well. Now we go take a look at the summary results. Stratigraphic profiles were made of the 37-30 and the 11-1 boxes, with a gap of 16.5 meters. Thinning upward reworked cycles were identified along the studied core, with the positional faces at the base and reworked grandstand faces at the top of each cycle. Two faces associations have been identified in the base and the top of the sample core. The first one is shallow lake deposit with the depositional faces, and the second is the gravity flows deposit, represent the rework faces. The faces associations 1 is composed of the faces shrubstone, laminated spherolightstone and shrubstone, and laminated mudstone. The shrubstone phase occur with different variations in the size and morphology. The first one pictures, we can see the crust morphologies. In the second pictures, we have the irregular morphologies, and the others, we can see pustular or arbustiform morphologies also. Here we have the thin upward rework cycles identified along the faces associations 1, with the positional face at the basin and the rework grandstand face at the top of each cycle. The silicifications occur both pervasively and by fully replaced layers with great porosity and permeability, such as the shrubstone layers. In the thin sections, we can identify the grandstones at the top of the cycles, with wood, spherulite, shrub fragments, and carbonated intraclast. Here, we can see the erosive contacts between shrubstone and grandstone, indicated by the red arrow. We notice that the shrub morphologies grew toward the top of the shrubstone faces, present pustular forms at the basin, passing to arborescent, and ending with the crust form at the top. This is a laminated shrubstone interlayer with spherolightstone faces, with very thin layers identified only in petrography. The thin sections present the spherolightstone parts of these faces, with calcite spherulites and the macrocrystalline dolomite cement. In the macro photography above, we can see the Dolomite Ridge at the top, like here. And in this macro photography, we have the shrubstone at the base and the spheroid stone part at the top. The faces associated to a gravity flows deposit are also composed of the thin upward cycles with rudstone at the base and grindstone or fine rudstone at the top. The cycles have erosive bases and are sometimes incomplete due to erosion. At the top, the faces are fluidstone with smaller and rounded clasts. There are also several silica nodules. Also, silicification is more pervasively by replacing layers. The faces association too is composed of the faces massive grindstone with wave ripples, massive rudstone, and floodstone with plane parallel bedding, and laminated mudstone. Uh, here we can see the basal rudstone that presents silicified imbricate tabula cluster of carbonates, grindstone, volcanoclast, and crushed mudstone. Here we find erosive contact, represent the top of cycles eroded by new one. And here, the grindstone with wave ripples are identified. They also exhibit an abundant occurrence of woods nucleated by spherulites and carbonate interclast. Now I will discuss the sedimentary model for the reworked deposit. These deposits are interpreted as coming from gravitational flows of fan delta with subaerial and subaqueous phases. The main features of the flow described are tabular imbricate clasts in the base of the flow represent turbulent flows, thin upward cycles with rudstone at the base and stratified grindstone at the top, erosive basin in the cycles, shrubstone and spheroid stone top reworked by the grindstone, wave ripples and woods in the grindstone and rudstone, possible indicated wave reworking, and in the end, dispersion of the fine particles due to flow deceleration in contact with the high basic shallow water lake. Uh, Based on the classical works like Nemec steel, the gravity flow is classified as the high concentrated fluidal sediment flow to subaerial conditions. However, newer works such as Mulder and Alexandre or Javala describe this type of flow as supercritical Newtonian flows of the concentrate or granular type. The main goal of this project is to create geological models for different depositional scenarios and zones of the Barra Velha formations. And this is a preliminary stratigraphical model developed by the team for the Upper Barra Velha formation. This model shows closed lakes between structural highs with a progressive decrease in the lake level. They also identify gravitational landslide from these highs that reach the lake. And the red circle highlight these gravitational flows related to the phase association described in this work. Uh, is in the end. And thanks so much for your attention. And thank you.